We also derived the expressions for average load current, and average load voltage. In this presentation, I will derive the expressions for RMS load current and RMS load voltage. RMS is an abbreviation for root mean square, and we call it root mean square because first we calculate the square, then we calculate the mean of a square, and finally we take the square root of the mean. So we have to calculate the root mean square value of load current and root mean square value of load voltage. We will first calculate the square of load current. Let's say load current is I. So first we will calculate the square of I, then we will calculate the mean of I square, and finally we will calculate the square root. Let's say the load current is I and we have to calculate I RMS, the root mean square value of load current, and it is equal to I square. Now I will calculate the mean by integrating I square from 0 to 2 pi with respect to omega t, and I will divide this by 2 pi minus 0 because this is what we do in definite integral, or I can write 1 by 2 pi. Now I will find out the square root. Of the mean, and the next step is to simplify this. From the last lecture, we know current I is equal to Im sine omega t, where Im is the maximum value of load current when omega t is from 0 to pi, and the load current I is equal to 0 when omega t is from pi to 2 pi. I will use this condition to perform the integration. We have 1 by 2 pi inside the bracket, integration from 0 to pi when omega t is from 0 to pi. I is equal to Im sine omega t, and we have I square, so I will write down Im square sine square omega t d omega t. This is what we have, plus pi to 2 pi. When omega t is from pi to 2 pi, I is equal to 0, so we have 0 here, d omega t, and I will represent the square root by making the power equal to 1 by 2. I have used the property of definite integral. If you have to integrate x with respect to dx from a to b, then it is equal to integration of x a to c plus integration of x from c to b. This is same as integration of x from a to b. In the next step, we will perform the integration. Integration of 0 is equal to 0, so this term will give us 0, and we are left with 1 by 2 pi integration 0 to pi Im square. Im square is constant, so I will take Im square outside, Im square, and we are left with sine square omega t d omega t 1 by 2. Sine square omega t, we cannot integrate it directly, so I will use the formula of cos 2 theta. It is equal to 1 minus 2 sine square theta. So sine square theta is equal to 1 by 2 1 minus cos 2 theta. I will use this to perform the integration. We have omega t in place of theta. Im square divided by 2 pi integration 0 to pi 1 by 2. This 1 by 2 inside the bracket, we have 1 minus cos twice of omega t d omega t. Very simple. Now we can easily integrate this. Integration of 1 is omega t, and integration of cos 2 omega t is equal to sine 2 omega t divided by 2. So Im square divided by 2 pi inside the bracket, we have omega t minus sine 2 omega t divided by 2. The lower limit is 0 and the upper limit is pi, 1 by 2. When you put the lower limit and upper limit and solve it, you will have Im square divided by 2 pi multiplied by pi. You will get pi when you put the lower limit and upper limit, 1 by 2. This pi and this pi will cancel out, and we have Im square divided by, this will be 4, this will be 4 because of this 2, here we have 4, so Im square divided by 4, 1 by 2, so this is equal to Im divided by 2. This is the value of RMS. The root mean square value of load current is Im by 2, a very important formula. After this, I will find out the expression for RMS value of load voltage. You can easily calculate the RMS value of load voltage like this by performing the integration and all, but I will not perform the integration because we have already calculated the RMS value of load current, and it is equal to Im by 2, and we know that Vrms is equal to Irms multiplied by the resistance, the load resistance, and Irms is equal to Vm divided by twice of R multiplied by R. This R and this R will cancel out, and we have Vm by 2 as the value of Vrms. So this is the another important formula that we have derived in this lecture. The RMS value of load voltage is equal to Vm by 2. I hope you now know how to obtain the RMS value of load current and RMS value of load voltage. I will end this lecture here. In the next lecture, we will find out value of form factor for half wave rectifier circuit, a very important parameter. First we will see what is form factor, then we will find out its value depending on the definition. So I will end this lecture here. See you in the next one.